magnesium hydroxide. Same treatment was given to this stream, and the quality of this stream was as good as our purified brine. So we were having recovery of sodium chloride here. So from this filtrate, we were recovering sodium chloride. This sodium chloride was going for electrolysis. We were producing HCl out of that, and that can be used there. So it was a closed loop cycle for wastewater. There was no wastewater as such from the neutralization of red mud, which remains a big issue in this type of process. This process is already patented, and Hindalco as well as Grasim has joined patent on that. Now I will be discussing few end use of this neutralized red mud. As you know, fluoride has been a big issue in some aluminum industries also. Even where the coal is being used, fluoride content is very high. If you are aware, wherever these coal beds or coal processing industries are there, the fluoride content in water is very high. It may vary from 3 ppm to 20 ppm depending on the leaching of fluoride from this species. We observed that removal of fluoride is very good between 6 to 7 pH. And we have identified that 6.5 pH is very good for adsorption of fluoride with aluminium. As the pH increases, there is poor adsorption or removal of fluoride using aluminium species. Other than that, we used RM for treatment of 100 ppm fluoride solution, and we found that for removal of 50 milligram of fluoride, we require 1 kg of RM. If fluoride concentration in water is 50 ppm, generally it is less, it may remain 5 to 10 ppm. So 1 kg of RM is required to bind the complete fluoride with this neutralized RM, because pH is near to 7. So removal of so removal of fluoride is very good. Other than that, we have also checked the leachability of this fluoride. So this was the fluoride synthetic water. We have 50 ppm fluoride, and we treated it with the neutralized red mud, and fluoride content was less than 2 to 3 ppm. At the plant scale, we took the same trial. This was the fluoride content in the inlet water that varies from 45 to almost 90 ppm, but the treated water contains fluoride content less than 3 ppm. So this may be a good option for treatment of fluoride rich wastewater for other purposes. After treatment, this was the characteristics of fluoride. This was the raw water containing fluoride, and this is the treated water coming out of that treatment. If you see, almost there was no addition of any heavy metal due to treatment with neutralized red mud. And fluoride content was reduced from 41 ppm to 3.8 ppm. We also did some leachable studies. So this column shows the RM red mud source. Is it neutralized RM or it is fluoride treated RM? This column shows water source. It is processed water or it is fluoride rich water, pH, agitation time, and fluoride content. So we took the neutral RM and passed processed water having pH 7.2 with 10-minute agitation time. There was the leachate which we got contain about 1 ppm of fluoride. Here we did complete mixing of RM with water, then we filtered it off. Similarly, with this neutral RM, we put fluoride rich stream containing 50 ppm of fluoride. At pH 7.2, fluoride content was 1.3. At pH 8.2, fluoride content was 3.8. Then this fluoride treated neutral mud where fluoride has been adsorbed or reacted with aluminium was treated with processed water, but there was negligible leaching of fluoride from this red mud. Although the time we increased the pH, there was little higher value, and the time we had this neutral red mud in cake form and pass the water over that, even passing it 10 times, there was very less leaching of fluoride out of this red mud. So red mud, neutralized red mud may be a good source for removal of fluoride in areas where fluoride has been an issue. The other industrial application may include ceramic industry. The time you have reduced soda content, it can be used in ceramic industry. It may be used for bricks manufacturing. In our plant, one separate plant is there who are working for manufacturing bricks. They have also used this red mud for road construction. So number of projects are going on. I have not considered these applications in detail here. This fluoride is also being used for tiles manufacturing, for cement manufacturing. Our Hindalco unit has MOU with our Ultratech plant, where part of raw material for aluminum and calcium has been replaced with this red mud and is being used for cement manufacturing without affecting any binding property of cement, and its mixing with other binder, it is also being used as good binder. Other than that, as I showed, it contains about 20% of alumina and 35% of iron. Extracting of this aluminum and iron, that is selective extraction of this aluminum and iron with acid, may result in good quality of coagulant, because both aluminum and iron are used as coagulant for water and wastewater treatment, as they are presence of few heavy metal. So not for drinking water, but this may be a cheapest source of coagulant for treatment of wastewaters containing dye, as there is combination of both aluminum and iron. We produced some quantity of coagulant and we found that against individual aluminum or iron, this was a very good coagulant for removal of dye from the textile industry wastewater. So if we see the benefits, the time we are neutralizing the red mud, it is environment friendly disposal and meeting norms for disposal of solid waste. It also addressed the issue of alkaline leachate that is coming out from the disposal sites. Neutralized red mud between pH 6.5 to 7 is a very good adsorbent for fluoride, and concentration can be reduced less than 1 starting from 50 ppm fluoride in the stream. During our process, we were able to purge a small quantity. I showed for this process, this plant, the quantity of wastewater generation was 3000 meter cube per day if we neutralize the complete wastewater, red mud. And due to recycling of process, the wastewater generation was only 100 meter cube a day. So it is 30 time reduction in wastewater generation. And whatever wastewater we generated, it was rich in salt. So we can recycle it back to chloralkali process and recover the value of both caustic and chlorine. So other than that, as I am in chloralkali industry, there are a lot of opportunity for academia to work on. Similar to red mud, in chloralkali industry, there is brine sludge. So per ton of about 4% of brine sludge is generated during production of caustic. And at village side, we are producing around 1,000 ton caustic per day. So around 40 ton of brine sludge is generated. The composition of this brine sludge is mainly barium sulfate, calcium carbonate, magnesium hydroxide, silica, and a few other residue. This is a very good source for raw material for cement industry. But the issue is the time it is being produced from chloralkali industry contain lot of chloride. Chloride content may vary from 7 to 8%. And for cement, we require little bit less chloride. So it is possible to have countercurrent washing. We have generated that data, but we may add more value to this sludge, which can be used as raw material to other industry. We are also having phosphoric acid plant. This phosphoric acid plant has IMI technology where phosphate rock is extracted with hydrochloric acid to produce technical grade or food grade phosphoric acid. During production of this phosphoric acid, there is production of calcium chloride water or calcium chloride solution. 1 ton of phosphoric acid results in around 9 to 10 ton of calcium chloride solution, which contains around 15% of calcium chloride concentration. So presently we are putting this stream to multi-effect evaporator, concentrate it first from 15% to 30%, then further in two stage we concentrate it to 48%, and then finally we produce calcium chloride granules out of this. That has very good value in oil exploration industry, then ice melting industry. But still, if we can work on this stream and can reduce the cost of conversion of calcium 15% calcium chloride to granule, where a lot of heat energy is required, this may be a good project in academy. So there are directional solvent where these salts can be directly separated out of this stream, may be a good option. Similar to this, there is phosphoric acid sludge. For 1 ton of phosphoric acid production, there is almost a ton sludge is generated that is rich in phosphates, calcium phosphate. Extraction of this value out of this sludge may be a raw material to other product, other process. So one of our industries working on that. We are mixing it with other fertilizers, and other fertilizers mean nitrogen and potassium, to extract the value of phosphorus and can be used for as customized fertilizer. In number of organochlorine compounds, compound industry, organic compounds are reacted with chlorine. So 1 mole of chlorine results in 1 mole of hydrochloric acid. And this hydrochloric stream may have some impurities and it becomes difficult to dispose of this HCl. So in our plant, we have chlorinated paraffin. We are going to have chloromethanes. So there is huge generation of hydrochloric acid. So we developed a process to purify this HCl. There was about 100 to 150 ppm of organic residue, and we adsorbed this residue on specialized adsorbent, and the quality of HCl is as good as virgin HCl and have added value. Earlier, this HCl was having the negative value, start having around 2000 to 3000 per ton. Now it is 4000 to 6000 positive value. Similar to that, we are also largest manufacturer of calcium hypochlorite. The time we manufacture calcium hypochlorite, sodium or calcium hydroxide is used to absorb the residual chlorine coming out of the process. Other than that, during manufacturing of high purity calcium hypochlorite, there is generation of bleach liquor that contain about 3% of chlorine. So disposal of this stream, that is volume is around 80 to 100 ton per day, remains a big issue. Neutralization is around 7 to 8 crore rupees per annum operating cost. But if we may find suitable use of this bleach liquor for disinfection or any process stream where it can be used for treatment of wastewater. So we have identified a process where it is being used to oxidize the organic molecules or removal of COD. So that's a very low cost treatment we have developed. Similarly, the time we are manufacturing aluminum chloride anhydrous, that is Fiddlecraft catalyst, during startup of the process or the time we are shutting down the process, there is huge quantity of aluminum oxide or chloride is produced. That remains waste. Good value out of this waste may be a good help to industry and may be reused back as raw material to this process. So in nutshell, there are numbers of opportunities in industry where waste coming out of industry may be a raw material to other process. Generally, what happens, the industry are concentrated on their production part and not giving much importance to these waste streams. But if we can identify these streams and may add value, this will be help to environment as well as it will be a sustainable model of operation. Thank you. Thanks a lot. If anyone is having any question, most welcome.
So now this is open for discussion. Anybody is having any question? Please continue. Sir, I am having one question, sir. Sir, you just
Yeah,
told
please.
You are preparing some virgin HCl out of the, and it is
Yeah.
having some added value. So just please tell me how you are doing that, sir. Just
Okay, so we have already filed the patent for that.
yes, sir.
So what we did, we identified a adsorbent
Yes, sir.
that was suitable to remove these organic impurities. So
Okay.
first we identified and developed these adsorbent in lab,
Mhm.
and then we had a pilot and then commercialized this process in the plant. So you have asked a very good question. It is not only that HCl having the impurity.
Yes, sir.
Due to non-handling of this stream, we were not able to run our plant. Sometimes the plant was shut because this hydrochloric acid was tanks were full. So development of this process not only had value to HCl, but we were able to run our plant at full capacity.
Yes, sir. Otherwise, it is a great problem to dispose of this much of HCl also that you are generating. So
Yes,
now,
yes. And just I am telling you figure, it was about 160 million rupees saving for a year after developing this process.
okay, sir.
So the numbers of this type of issues remaining in industry and may help industry to uh, support and to overcome of these issues.
Yes, sir. Generally, industries they focus on production, but आज Aditya Birla
Yeah.
it is doing so much on the value addition also. That a great thing, sir.
Yes. Yes. Ma'am, yes.
So, any question from the audience side? So it is a nice presentation, sir. I liked it very much, sir. Okay.
Thank you, madam.
Thank you.
Thank
So
you.
thank you, sir.
Thank you. Thanks a lot. Thanks a
Uh,
lot.
Okay, sir. And the participants, tomorrow the session starts at 10 o'clock. So hope to meet you all during that time. So here I end the meeting for the today's session. So thank you, sir. Thanks a lot.
Thank you, madam. Thank you.
Okay.
Thanks a lot. Thanks a lot.